Hello, grade 11, Harold, grade 11. We look at this book, Engineering, Graphics and Design, grade 11 by Johan Engelbrecht, chapter 6. Chapter 6, solid geometry. We are going to look at task number 3. This figure shows the front view and the auxiliary view of a right regular solid. It's a solid which is a pyramid in this case. Draw the following, as well as the cutting plane AA. Draw the following. A given front view. This is the given front view. A sectional top view. Draw the top view. All hidden details must be shown. A sectional left and a true shape. All constructions must be shown. They would require us to draw the front, the top, and the left. First angle orthographic projection. So you want to place your drawings towards to your left, your front and top. It must be towards your left hand side. So, but first of all, you start with this one, which is the auxiliary drawing. You start drawing the auxiliary. That's the one that is helping us. Auxiliary means helping. Auxiliary view is a helping view. We would like to start with the auxiliary view. Draw the auxiliary view. It lies at an angle of 30 degrees, this front view, which means this side of 20 millimeters is at an angle of 30 degrees. So we have a special 30 degrees is a special angle. It's a special set square. The ones that we use in EGD, special set squares. Obviously with the T-square firmly placed, you have already your 30 degrees. That will be your 30 degrees. And then from the 30 degrees, it says each side is 20 millimeters. So we will measure 20 millimeters. Start doing our auxiliary hexagon, which is 20 millimeters each side. Each side is going to start here, maybe probably here. Then we measure 20 millimeters. That is our 20 millimeters. Perpendicularly at 90 degrees. Perpendicularly, which means at 90 degrees. This is at 90 degrees. That's perpendicularly, okay. I'm just hurrying up things here. I'm looking for my rubber. My line, I don't like it. Fortunately, I do have a rubber that assists me all the time. That is there. And then also here, this is 90 degrees. 90 degrees. Remember, 1, 2, 3, 4, 5. It's a pentagon. 5 sides. 360 divided by 5 gives us 72 degrees. You will want to have your own protractor. A protractor that will help you there. Constructing that. You align it to 0 and 90. 0 and 90. So it is 60, 70, 72 degrees. And also this side is 0 and 90 degrees and 0. 0 and 90. 71, 72 degrees. Then you will have that. That is your angle of 72 degrees. This angle is 72 degrees. But we know that this is 20 millimeters. Another 20 millimeters where they intersect. That's 20 millimeters. Then I'm able to join. Yeah. I'm able to join. It's my pentagon. Now I'm forming my pentagon. You don't want to make this solid. It's not solid. It's for the purpose of visibility here that I'm making it solid so that you are able to see nicely. Anyway, there is my pentagon with 5 sides. Then now I want to get to the apex, to the tip of my hexagon, this middle part here, tip of this pyramid, this part here. How do I get to that? By getting a perpendicular bisector. You bisect to any two lines. Just make it just a little bit over half here. You do that and that. And then you transfer that one to the other side there and there. That is one perpendicular bisector. This one from here up to there. This line that I've constructed, it bisects this line at 90 degrees. It cuts it into two equal halves. And I will do the same to any other line. Any other line. In this case, I will choose this one. This one, I'll do that. That. And then where the two intersect, this line, it intersects here and there, here, there, and there. That is my perpendicular bisector. This line at 90 degrees, it has been cut into two equal parts. So where this perpendicular bisector and that one, when they meet here, you will have your center, you will have your apex, your tip. The tip of the pyramid, pentagonal pyramid. There we are, there. I'm completing now. I'm completing my pentagon. There we have my pentagon being completed there. So at 90 degrees, guys, at 90 degrees, this line that I've drawn here, I've drawn it at 90 degrees to that one, to my 30 degree line at 90 degrees. It will be I'll call it X1, Y1, because it's for auxiliary. It's a ground line for auxiliary. I'll explain something later on. And then I will want to project this center, that corner, which is in line with that one. And then we have that one also. Okay. Yeah. So what do we do then? We start making the front view. This is the front view. We're drawing the front view. The front view, the height of the front view is 60 millimeters, and up to the cutting plane is 38 millimeters. I will measure 60 millimeters. Okay, I'll start here, maybe probably here. From here it will be the base of my pyramid, and then there will be my 60 millimeters. 60 millimeters will be there, and my 38 millimeters will be there. Let's check. I'm going to complete my YouTube like that. I know that most of you are able to complete that. And then where was my 38? Oh, my 38 was here. Let me just verify. Yes, this was my 38. My 38 at 90 degrees. Remember, at 90 degrees from here, this line. At 90 degrees, it is somewhere there. It touches there. My 38 will be somewhere there. It is there. Not somewhere, it is there. And then on this side it's 8 millimeters. 8 millimeters. This 8 millimeters. There is my 8 millimeters. And then that will be my cutting plane. That will be my cutting plane. My cutting plane. That will be my cutting plane. My cutting plane is A. That is my cutting plane A. And then this auxiliary, it has helped me. This helping view has helped me to draw this part, this front view. So let me name it. Maybe my apex, my tip will be 0, and then here 1, 2, 3, 4, 5, pentagon. So this line, it is 1 nearer, 1 furthest is 3, and that one is 2. That's here nearest is 5 and 4, and that one is 0. Now I have redrawn my front view. I'm done with my front view now. Now they want the top view. My top view will be here. I'll draw it below here. The top view. This is front and top are the principal views, the most important views, the main views. So the ground line here. This is the main ground line. X, Y line. They will call it XY line. This one, just to differentiate, this one is X1, Y1, to differentiate it from this one. So now I'm going to draw the front view from this side. Now I'll have my front view on that side. Maybe it is too long. It may interfere with my view. Okay, this is an erasable pen. I don't know what is happening here, but you are not supposed to use a pen. Don't use a pen. Right? Don't use a pen. It's fine. I was trying to erase something there, but nevertheless, it's not a tidy work anyway. Sorry about that, but the crux of the matter is we have to do the top view. We project 1, 2, 3, 4, 5 corners. Those 5 corners, we projected them, and then from our helping view, auxiliary, we are being helped by the auxiliary view. We will start from the ground line. Here is my ground line. From the ground line to 1. Where is 1? 1 is here. There is 1. 1 and 3 are here. From the ground line to 1, I measure here from the ground line to 1. That is the distance. Now here is 1. It goes up there. From the ground line, my 1 will be here. My 1 will be here. There will be my 1. And then my 2. 2 again, from the ground line to my auxiliary view to 2. There is 2. From the ground line to 2. Now it's going to be also this side. From the ground line, I will get 2 here. Ground line, there will be 2. And then from the ground line to 3. Ground line, there is 3. Ground line to 3. Now where is 3? 3 is here. Ground line to 3. This will be my 3. Ground line to 4. Here is 4. Ground line to 4. Ground line to 4. 4 is here. Here is the ground line, and my 4 will be here. 4 is here. And then ground line, from the ground line to 5. From the ground line to 5. 5 is in the same line as 4. From the ground line, my 5 will be there. My 5 will be there. 5. Now, 1 is joined to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 1. I do the same here. Very faintly, 1 is joined to 2, 2 is joined to 3, 3 to 4, 4 to 5, 5 to 1 base, and then all of them they converge at 0. 1 to 0, 2 to 0, 3 to 0, and so on. 2 to 0, 4 and 5 to 0, and so on and so forth. Now let's find 0. Where is my 0? So my 0 is from the ground line, to 0. Ground line to 0, ground line to 0. So my 0 is there. 0, my hero. My 0 is there. So 1 goes to 0, 2 goes to 0, 3 to 0, 4 to 0, 5 to 0, very faintly. It's a little bit darker from my side because of picture quality. Pictures of picture, but 4 to 5. There is 4 to 5. There, so on and so forth. Now coming to the cutting plane. Now we're going to draw the cutting plane. The cutting plane, where does it cut? Let's check. It cuts 2 here. There is 2. 2 is cut here. 2 is cut here. There is 2 is cut here. And then it cuts 1 and 3 here. 1 and 3 is cut here. 3 and 1, they are cut here. 4 and 5. Here is 4. Here is 5 behind 4. 4 behind 5. They have not been cut. They have not been cut. Where is our cut? Where is our cut? Everything has been started cutting here. 1, 3 and 2, they are not there. Everything has been cut here. It has been cut here. Everything has been cut here. Now, let's check. Let's check where do they end. Where do they end? Now, we will start with 3. 3 has been cut here. And 1 has been cut here. So, just for you to be able to see, this is the cut of 1, this is the cut of 3, that is the cut of 2. It's just for your information. You don't have to do this. It's just that I'm explaining for you to be able to see that. Now, from the base, let me extend the cut from the base. Let me extend this cut. Look, 4 and 5 has not been cut, but as 4 moves towards 3, it's cut there. Even here you can see, as 4 moves towards 3, and as 5 moves towards 1, it's cut there. Here are those 2 cuts, if you can see, which means 1, 2, 3, they are no longer there. Everything has been cut. 1, 2, 3, they are no longer there. As 4 moves to 3, we said as 4 moves to 3, it was cut here. And as 5 moved towards 1, it was cut here. So 1 is no longer there. You'll never have 1. 1 ends here. Since it was cut here. Now, let us join the cuts only. Join the cuts. Remember, when we start joining the cut now, we will say 1 is no longer there. It has been cut. Everything has been cut up until here. Up until here. Remember, that is 1. 1 will go the outside perimeters, the outside ones. Obviously, you are going to see them. We're looking at it from the top. So, from 1, it was cut here 1. It will go to 2, 2 to 3. Let's do that. From 1 to 2. 2 to 3. 3 ends there. And then 3, because it ends there, it will move up to here. The cut will move up to there. There will be the cut. because the cut moves right here. From here it will go there. The cut will go there. From here it will go there. The cut will go there. The cut will go up here. And then from here, because this has been cut right through up to here, giving you the cut from 3 to this side of 4. 5 goes up to here. So the cut